Hi everybody. Today what we're going to look at is doing change detection analysis. Here in the United States, we just had Hurricane Laura go through, and what we're looking at right now is Landsat 8 images of the area in which the eye wall made landfall. Okay, this is the Lake Charles, Louisiana area, and what we're going to do is we want to find out the inundation of flood from either the storm surge or the amount of rainfall in this particular area. There are two basic ways of doing change detection. The most obvious is just using your own eyesight and looking at the before and after image and see if you can visually detect any change. It's kind of a big duh, right? All right, so to do that, there's a couple different ways. We can have both images up like I do. Like I said, this is Landsat 8. This top image, pre-Laura, was August 13th. The post-Laura was August 29th. Both of these images are mapped with bands 5, 6, and 4, respectively, mapped to the RGB. 5 being near IR, 6 being the mid IR, and 4 obviously being the red band. Okay, this band combination allows for one of the best ways to detect boundaries between water and land. In this band combination, water is going to show up in variations of black because water absorbs infrared light, whereas vegetation is going to show up in browns, oranges, and greens. Okay. You can also use this band combination for doing crop analysis too, but it's also one of the best to show the defining boundaries between land and water. All right, so let's take a look at this image from August 13th, and we're at Lake Charles, Louisiana, to the southeast portion right here. Okay, we see this land got a lot of orange, green, and browns in this area, showing farmland and things like that, grasslands and stuff. All right, if I turn that off, underneath is the after. And this image changes dramatically visually. Notice that these areas have now turned to darker browns and blacks and things like that. That tells me that there is water on the ground. This is inundated with floodwaters, all right? But visually, unless you know the area and you're good at guessing calculated areas, you can't get a numeric value of the number of acres or hectares or whatever in this area. You need to do a little bit more analysis. And that's where unsupervised classification comes in, okay? Now, we're not going to do the entire Landsat scene. We need to do a small study area, and what I've done is I've created a shapefile with a small area that we're going to use, and I believe it is right here, Laura study area, which is just a simple rectangle that I made. Let's symbolize that so we can see it a little better here. We'll make that transparent. Outline, let's turn that red. Make it a little thicker red, hit OK. Now we got a red box, okay? This is our study area. This is the only part of the image that we want to do any analysis of, okay? Now, If you have Image Analyst installed, you want to bring up those Image Analyst tools. You can just come up here to the Windows and choose Image Analyst, and it will bring up the Image Analyst tools, all right, or dialog boxes. If you want to dock this to your Windows, just come over here to a spot and just drag and drop on that little image, and it will pin it to your frame of your window, so it's always in the same spot. All right, now you can also do what is called to go from one image to the other. You can turn the images on in this window right here. Okay, let's put a check mark there so we have both images. And I got the pre-hurricane image loaded on top, so I highlight that, and I come down to this little tool that says swipe layer. Now if I take my mouse, which is now turned into a black triangle, and I just slide that back and forth, I can see the changes from one image to the other. What I want you to do is I want you to keep an eye on this little ridge right here, this eastern boundary of Lake Charles. As I slide it, you notice that it's also in the after image. So that tells me that that's high ground that wasn't inundated by the flood. It's kind of like a dike or a dam or something, okay? But if you slide this back and forth, you can see the change from one image to the other, all right? But we don't want to use the whole image. I want to clip the images just to use our study area. Okay, so we're going to come over here and we are going to do a raster clip. And we are going to clip these images to just be inside the red box. So I'm going to double click clip. And I'm first going to do the pre-LoRa, and I'm going to left mouse click and drop that into input raster. Our output extent is going to be our study area shapefile, and I want to retain that boundary. And we're just going to call this we'll call it pre-L. And hit save and then OK to clip that image. All right, this might take a few seconds. Bear with me here. All right, so right now is we are taking this large image and we're only keeping what's inside the red box. So we have a smaller data set to work with. That way our processes don't take as long. All right, now that that's done, I want to do another clip. But I want to clip the image for after the hurricane. So I double click clip, and I want to come to the after image, which is this one here, and I'm going to drop and drag that into input raster. Our output extent is still the same study area. Click geometry, and then we're going to give it a new name, and we're going to call this post L. And we're going to click save, and then we're going to clip that one. So we're going to have another data set that's of the post image in our study area. Okay, that will make all of our processing a little quicker. All right, now that I have the two clipped images, I don't really need these two images here, so I shift right click and remove those from our table of contents. So now I just have our study area, and then I can zoom to that layer to have a bigger view. Now if we come over to our image analyst toolbar here, and I notice that my post L and my pre L are both check marked. If I select my pre-L and I come down to my slider tool, as I, whoops, let me try this again. Highlight the top one, and as I slide it back and forth, you can see the two images on top of each other. Now, one thing that we have to do, well, you don't have to, but it'd be sure helpful, let's make these look like they were before by getting the right band combinations, which are 5, 6, and 4. Red is 5, green is band 6, and blue is band 4. So now our images look like they did before, except a smaller area. Okay, so there's before, and there's after. Before, after. So you can kind of see where some of the changes were from before the hurricane came through and after. All right, this is our proposed flooded area here, this darker area. All right, the other obvious changes that you see from one image to the other are obviously the clouds. Okay, so here's where the clouds were the day that the image was taken before the hurricane, and then there's where the clouds were after the hurricane, these little puffy white things and pink things, right? Okay, now you have both images, and you can visually inspect by using your slider and back and forth, but we need some mathematical data. We need some area. You know, we want it to calculate the area of change from one to the other, right? Okay, so what we're going to do is we're going to do what is known as an unsupervised classification. That is, allow the software to go in and detect any change from one image to the next, and then set up a criteria for us to see different areas of change. All right, so what you want to do there is, in this image analyst, is that you want to shift and click both of these images, and then come down to under where it says processing now, but down here you'll see a green and red layer button where it says difference. If you click that button, it is automatically going to go and calculate the differences between the two images and code them. Okay, so that happens relatively quick in a small area like this. So here's our change image, and notice we got white clouds here, and then we got black clouds here. Okay, this is where the clouds were in one image, and white was where they are in the other image, right? But we have some subtle differences that you can't really detect in this area here. Okay, so if I go to our difference raster image, and I click the slide tool, you'll notice that you can see some subtle differences between the two images. All right. Now our next step is, what we want to do is we want to create actual classes. We want to do analysis, go into our difference layer, and color code any differences that it finds. Now your eye in this particular image that we have up on the screen really can't, other than the differences in the clouds, can't see the differences that were on the ground. So we're going to let the software do that for us. So up here in this classification menu, if it doesn't show up, right click anywhere in the menu and make sure that image classification is turned on. All right, and then you'll have this classification menu bar right here. All right, so we're going to make sure that difference is selected, and we are going to go to classification, ISO cluster unsupervised classification. It automatically puts the difference in there for us, and we don't need to do the raster bands and stuff. But what we want to do is we want to add in how many classes do we want it to classify for us. Now, the more classes, the better. You can fine tune and get exact, more precise data. The more classes that you have, however, that makes you do a little bit more work later on. But for now, we're just going to say, show me 5 classes that you find that are different. Okay, so I did 5 classes, hit OK, and what it's doing right now is doing that unsupervised classification. When it gets done, we get a new raster, and in that raster, it shows us all the different things it thinks is change. All right? Now, what really is change in this? All right? Well, we know that this dark green right here with some of this orange around it, we know just from looking at the image that those were the clouds. Okay, so we're not really concerned with the clouds. What we're concerned about are these little gray areas, the purple areas, and the green areas. Okay, because those are 3 out of the 5 classes that it shows for change, right? So how do we know which ones to look at as change? All right, now visually, we know that both images, pardon me, both images, Lake Charles was black, right? Well, it's showing up purple now. So we can almost assume that any purple that we see is something that is the same from one image to the next. All right, so I'm going to choose this difference layer, and I'm going to hit the slider tool, and we're going to, well, let me turn difference off here. We're going to slide this back with our unsupervised classified raster, and notice that the purple does indeed show up in Lake Charles, and it also shows up in the Gulf of Mexico, which is down here. All right, now if I turn off the post and go to the pre-image and I slide back and forth, what do I see here? All right, now in my pre, I'm seeing the purple is black before the hurricane. Okay, all the purple that you see now, some of it you can't see. There's some subtle differences up in this area here, but a lot of that purple was already there prior to the hurricane. Okay, now some of the purple is black from the shadows of the clouds. All right, but the green areas is land, is like cropland, right? Now if we come over and turn back on our post image, slide this back and forth, we notice that cropland is now black, right? Okay, so that is the data that we're going to be looking at. All right, we want to see what has changed, not what was already there. We saw that most of the purple was black in the pre-hurricane image, but the green was not. Okay, so what we're going to do is we're going to take this new raster image that it's created, this classified image, and we are going to only extract out that green area so we can do how much area has changed from one image to the other with respect to with the exception of where the clouds were. Okay, so what I'm going to do is I'm going to open up the attribute table of this raster, and I know that the light green is class 2, and I want to select class 2. Okay, value number 2. All right, I want to make sure that that's selected. All right. Now I want to come over to my search and I want to type in raster to polygon. Whoops, use the correct fingers here, sorry about that. Raster to polygon. And we're going to use the raster to polygon tool. And we're going to double click that tool. And we are going to drop in our raster class unclassified image. And we are going to, well, I'm just going to use the temporary file name. That'll be fine. And since I only have class 2 selected, it's only going to convert that value into polygons. So I'll click OK. And after it chews on that for a little bit, all right, we get this new shapefile. I'll turn off the unclassified. And we get this new shapefile. Notice that we have all these little polygons. These are all those value 2s that we said were most likely changes from one image to the next, right? So if I right click that and open up the attribute table, we get shape area, okay? We find out how much area is in each one of these polygons, and we can simply do right click and do a statistics on that field for shape area to find out how much area has changed from one scene to the next. And if we look at sum right here, we see that we have, what is that, that's hundreds, thousands, we have 290 million square feet of change from before and after the hurricane. Now, if you want to make this make more sense, we can right click, add a field. Let's call this acres. Let's make this a double field. Hit OK. We have a new field called acres, and I can right click, do a calculate geometry, and we're going to make area, and we're going to make those units acres, US acres. Click OK. Select that, let that do its job. All right, and then I can do a statistics on acres, statistics, and find out that we have 71,796 acres of change from before to after the hurricane has gone through. So you can use that for some change detection. So this was just a simple exercise in a simple change detection. If you have any comments, leave them below. I welcome all comments. Please make them polite, okay? I know people do things a lot different. This is just one way of doing things, and I have a lot of friends out there in the industry that do them different ways, and that's okay as long as you get the results that you need. So leave a comment, subscribe, and push the bell for notifications for more videos, and we'll see you guys on the next one. We'll see you later.